Hello and welcome back. So today we're doing a topic on operating systems. The topic is scheduling algorithms. Introduction. So CPU scheduling deals with the problem of deciding which of the processes in the ready queue is to be allotted to the CPU. The following are some scheduling algorithms: FCFS scheduling, first come first serve; SJF shortest job first; round robin scheduling; SRT scheduling, priority scheduling, multi-level queue scheduling, multi-level feedback queue scheduling. FCFS scheduling. The process that requests the CPU first is allotted the CPU first. The implementation is easily done using an FIFO queue procedure. When the process enters the ready queue, its PCB is linked onto the tail of the queue. When the CPU is free, the CPU is located to the process at the queue's head. The running process is then removed from the queue. Advantage: the code is simple to write and understand. The disadvantage is the convoy effort. All other processes wait for one big process to get off the CPU. Non-primitive: a process keeps the CPU until it releases it. Not good for time sharing systems. The average waiting time is generally not minimal. SJFF scheduling. The CPU is assigned to the process that has the smallest next CPU burst. If two processes have the same length CPU burst, FCFS scheduling is used to break the time. For long-term scheduling in a batch system, we use the process time specified by the user as the length. SJF can be implemented at the level of short-term scheduling because there is no way to know the length of the next CPU burst. The advantage is the SJF is optimal, that is, it gives the minimum average waiting time for a given set of process. Disadvantage: determining the length of the next CPU burst. SJF algorithm may be either non-primitive or primitive. Priority scheduling. The priorities associated with each process. The CPU is allotted to the process with the highest priority. Equal priority processes are scheduled in FCFS order. Priorities can be defined either internally or externally. Advantage: higher priority process can be executed first. Disadvantage: indefinite blocking, where low priority processes are left waiting indefinitely for CPU. Round-robin scheduling, designed specifically for time-sharing system. It is similar to FCFS scheduling but with permutation. A small unit of time is called a time quantum or time slice. Time quantum is ranges from 10 to 100 ms. The ready queue is treated as a circular queue. Advantage: higher average turnaround than SJF. Disadvantage: better response than SJF. Multi-level queue scheduling. Useful for situations in which processes are easily classified into different groups. For example, a common division is made between foreground or interactive process and background or batch process. The ready queue is partitioned into several separate queues. The processes are permanently assigned to one queue based on some probability like memory size, process priority, or process type. Each queue has its own scheduling algorithm. Multi-level feedback queue scheduling. The basic idea is to separate processes according to the features of their CPU burst. For example, if a process uses too much CPU time, it will be moved to a lower priority queue. This scheme leaves IO-bound and interactive processes in the higher priority queues. If a process waits too long in the lower priority queue, it may be moved to a higher priority queue. This form of aging prevents starvation. Thank you. Do you like the video?